right, so today we're going to be working with integer exponents. Do you guys know what an integer is? Somebody give me an example of an integer. Aren't they just like numbers? They are, but what kind of numbers? Are they only positive? They could also be negative. So they're like whole numbers, but they also can be positive. So it's all the way from negative infinity to positive infinity, but there's no fractions or decimals, right? So when I'm talking about integer exponents, what I'm specifically thinking of are negative exponents. So for instance, if I have x to the negative n power, turns out it just equals 1 over x to the n power. So all you have to do to deal with negative exponents is first flip it, take the reciprocal, right? And then you want to make sure you remember to change the sign of the exponent. Okay, we're only changing the sign of the exponent. We're not going to change the sign of the base. Okay, so for example, if I have 2 to the negative 4 power, that means I'm just going to flip it over and make the exponent positive. So instead of 2 to the negative 4, now it's 2 to the positive 4 power. So 2 to the 4th just means I'm multiplying 2 times itself 4 times. So 2 times 2 times 2 times 2 is 16. And so that would be the simplified form of that. Okay, so how many of you guys brought your whiteboards with you today? Okay, go ahead and get them out. Okay, so you just had to flip it over, make it 1 over 10 to the positive 4th, which is just 1 over 10 times 10 times 10 times 10. So what's the rule with multiplying by 10? A 0 for each one, right? And so since it's 10 to the 4th, I'm going to have 4 zeros. So it's 1 over 10,000. Okay, here's another example for your notes. All right, so I've got negative 5 to the negative 4. So do I have parentheses on this one? No, there's no parentheses. So what that means is my base is actually positive. It's actually a negative 1 times a positive 5 to the negative 4 power. Okay, so what that really is negative 1 times 5 to the negative 4th power. So that's going to equal negative 1 times 1 over 5 times 5 times 5 times 5, right? It's 5 to the 4th power. And so that ends up equaling negative 1 over 625. So on your whiteboard, I want you to do negative 6 to the negative 2 power. Okay, so it looks like most of you are getting it. It's going to be negative 1 times 6 to the negative 2, so it comes out to negative 1 over 36. All right, now for this one, oh, that didn't work too well. Okay, for D, I've got negative 2 in parentheses raised to the negative 4 power. So this time my base is negative 2. So that means that I'm doing So first of all, it'll be 1 over negative 2 to the positive fourth power. I'm doing 1 over negative 2 times negative 2 times negative 2 times negative 2. My base is negative 2, so that's getting multiplied every time. What's it come out to? Positive or negative? It's going to end up being positive because the negative times the negative is positive, and we do that twice. So whenever you have an even exponent, it's going to come out to a positive number if you have a negative base. So we get 1 over 16 again. All right, and here's one more for your notes. Okay, I have negative 0 to the negative fifth power. So there's no parentheses, so it's negative 1 times 0 to the negative 5. Well, the problem is, if I flip this over, am I allowed to divide by 0? No. So this is actually undefined. We can't ever raise 0 to a negative exponent. Good, so here's another whiteboard one for you. Okay, this one is going to be negative no matter what, right? Because it's negative 1 times 5 to the negative 2. So that's negative 1 times 1 over 25, so negative 1 over 25. All right, here's one more. Oh, whoops, that's supposed to be to the negative 4, my bad. Negative 3 to the negative 4. Sorry, I forgot to. Yeah. No. Uh-huh. Uh-huh.
What's that as the first time?
Okay, so you get 1 over negative 3 to the fourth. That's just negative 3 multiplied 4 times. So 1 over 81. It comes out positive. Okay, now we're going to talk about the 0 power. Any non-zero number raised to the 0 power is going to equal 1. And it's important that it is a non-zero number, because again, you can't divide by 0, and so that's where it comes from. So if I have 7 to the 0 power, that equals 1, okay? It's not going to equal 0, it's going to equal 1. Here I've got 8 times 23 to the 0 power. What's being raised to the 0 power in that problem? Just the 23. So it's 8 times 1, so it equals 8. And then can I raise 0 to the 0 power? No, that's undefined. You cannot do that. It has to be a non-zero number. So I've got a couple for you guys on your whiteboards. Let's do this. Do that one first. Okay, so what's it equal, everybody? It equals 1. Okay. Now let's do this other one here. Okay, so what is 543 to the 0 power? 1. And 729 is not being raised to any power, so it's just 729. So it equals 729. Okay, questions? Okay. All right, so now what we're going to do is we are going to evaluate each expression for the given variables. So if x equals 4, and I've got x to the negative 2 power, that means I've got 4 to the negative 2 power. So what do I have to do to it? Flip it over and make the exponent positive. So it's 1 over 4 to the positive 2 power. So that would be 1 over 16. All right, this one, they made it a little bit more complicated. I've got negative 2 times a to the 0 times b to the negative 4. And a is 5 and b is negative 3. So we're just going to plug it in. So negative 2 times 5 to the 0 power times negative 3 to the negative 4 power. Okay, so negative 2, nothing happens to that. And 5 to the 0 is equal to 1. But what do I have to do to the negative 3 to the negative 4 power? I have to flip it over and make it a positive 4. So 1 over negative 3 to the positive 4th power. So on top, I've got negative 2 times 1 times 1, that's negative 2. And what's negative 3 raised to the 4th power? We just did it not too long ago. Came out to a positive 81, yeah. So that would equal negative 2 over positive 81. All right, so this next one I want you to do on your whiteboard. Okay, so that was 4 to the negative 3rd, which is 1 over 4 cubed. So look like most of you got 1 over 64. All right, one more for your whiteboards here. 8, a to the negative 2, b to the 0, where a is negative 2 and b is 6. Okay, so we have 8 times negative 2 to the negative 2 power times 6 to the 0, so that's 8 times 1 over 4 times 1. So you end up with 8 over 4, which is 2. Okay, now sometimes you may end up having a negative exponent that's in the denominator. Well, it's still the same steps as before. You're going to flip it, and you're going to make the exponent positive. Change the sign of the exponent. So when I flip over 1 over x to the negative 8, now my x is on top, I have a 1 on the bottom. Do I need to write the 1 on the bottom? No, it's just x to the 8th. Okay? So one way you can think of it is that if you have a negative exponent, he's sad. And when you move him, then he's happy. Okay? But if you have a positive exponent, he's already happy, so just leave him alone. Don't move it. Okay, so whenever you have a negative, you're going to have to move it. If the negative is on the top, you move it to the bottom. If the negative is on the bottom, you move it to the top. Okay? So here's an example. 7 times w to the negative 4. What is being raised to the negative power here? Just the w. The 7 is not being raised because there's no parentheses around the 7w. So that means that the w, he's not happy. That has to go to the bottom. So if you think of it, then you've got 7 over w to the positive 4. You moved him, now he's happy, so that the exponent's positive 4. Okay? So on your whiteboards, let's do that one. 5 times x to the negative 3. Okay, so he's got to move down. The x isn't happy. So the 5 stays put. 5 is perfectly happy. We assume it's to the positive 1 power. And you get 5 over x cubed. Okay, another one for your notes. We've got a negative 5 over k to the negative 2 power. And so this time, who's unhappy now? Just the k is unhappy, okay? Because the negative 5 is being raised to the positive 1 power. Remember, we're only talking about the exponents, not the base. It's okay if the base is negative. But if the exponent is negative, that's when it has to move. So the negative 5 actually is perfectly happy. He just tends to be negative, I guess. So we've got negative 5 times k to the positive 2 power. And there's nothing left on the bottom, so do I need to put it over 1? No, I can just leave it like that, okay? All right, so here's one for your whiteboards. Okay. Okay, so who's not happy? The r to the negative 6, right? So it's going to equal 7 r to the 6th. All right. Now for this one, okay, it's starting to get a little bit more complicated. I've got a to the 0, b to the negative 2 on top, c to the negative 3, d to the 6th on the bottom. So I've got two guys that aren't happy, right? Who's not happy? The b and the c. So the b isn't happy, he needs to go to the bottom, but the c isn't happy, he needs to move to the top. So we only move the ones that are negative. What is a to the 0 power? It's just 1, and then we'll have c, and now it's to the positive 3 power. I moved it, he's happy. And then on the bottom, I've got my b to the positive 2, d to the 6th. And so you don't really need to have the 1. It would just be c cubed over b squared d to the 6th. Okay? So you just move the ones that are negative. All right, so on your whiteboards, you've got 2x to the 0 over 7y to the negative 10. So only move the thing that's not happy. Uh-huh. Okay, so x to the 0 is just 1, right? So we can pretty much ignore that. And so we've got 2 times 1. I need to move this to the top, so times y to the 10th. And 7 was perfectly happy, should have stayed on the bottom. So we get 2y to the 10th over 7. Okay, one more of these. All right, we've got x squared y to the negative 8 over m to the negative 2 n to the 0 power. Okay, so y isn't happy, and m isn't happy. So we end up with x squared, m squared on top, and y to the 8th on the bottom, because n to the 0 is just equal to 1. All right, so let's just make sure you guys have these down. Let's go ahead and do this one on your whiteboards too. Okay, so on the first one we had 2 over m cubed. The second one we got 1 over 7r cubed. And what's our last one? G to the 4th over h to the 6th. Thank you.